Solve the system. Check the solution if possible. X minus 2y plus z equals negative 11. 3x plus 2y minus z equals 7. And negative x plus 2y plus 4z equals negative 9. Let x minus 2y plus z equals negative 11 be equation 1. 3x plus 2y minus z equals 7 be equation 2. And negative x plus 2y plus 4z equals negative 9 be equation 3. You want to begin by rewriting the system as a linear system in two variables. To do this, add equation 3 to equation 1, giving you 5z equals negative 20. This can be simplified by dividing each side by 5, leaving you with z equals negative 4. Now add equation 3 to negative 3 times equation 1, giving you 8y minus 4z equals 40, which can be simplified by dividing each side by 4. Now you want to solve the new linear system for both of its variables. To do this, substitute z equals negative 4 into 8y minus 4z equals 40. Negative 4 times negative 4 is 16, so you have 8y plus 16 equals 40. To solve for y, first subtract 16 from each side, giving you 8y equals 24. Then divide each side by 8, leaving you with y equals 3. Now substitute y equals 3 and z equals negative 4 into an original equation and solve for x. Substituting y equals 3 and z equals negative 4 into x minus 2y plus z equals negative 11, you get x minus 2 times 3 plus negative 4 equals negative 11. Negative 2 times 3 is negative 6, and adding negative 4 is the same as subtracting 4. Combining like terms, you have x minus 10 equals negative 11. To solve for x, add 10 to each side, leaving you with x equals negative 1. So you have x equals negative 1, y equals 3, and z equals negative 4. Now you want to check this solution. To check this solution, substitute x equals negative 1, y equals 3, and z equals negative 4 into each of the original equations. First, substitute these values into x minus 2y plus z equals negative 11. Negative 2 times 3 is negative 6, and adding negative 4 is the same as subtracting 4. Negative 1 minus 6 minus 4 is negative 11. Because negative 11 equals negative 11 is a true statement, x equals negative 1, y equals 3, and z equals negative 4 is a solution of the equation x minus 2y plus z equals negative 11. Now substitute the solution into 3x plus 2y minus z equals 7. 3 times negative 1 is negative 3, 2 times 3 is 6, and subtracting negative 4 is the same as adding 4. Negative 3 plus 6 plus 4 is 7. Because 7 equals 7 is a true statement, x equals negative 1, y equals 3, and z equals negative 4 is a solution of the equation 3x plus 2y minus z equals 7. Now substitute the solution into negative x plus 2y plus 4z equals negative 9. The negative of negative 1 is 1, 2 times 3 is 6, and 4 times negative 4 is negative 16. 1 plus 6 minus 16 is negative 9. Because negative 9 equals negative 9 is a true statement, x equals negative 1, y equals 3, and z equals negative 4 is a solution of the equation negative x plus 2y plus 4z equals negative 9. So the solution is x equals negative 1, y equals 3, and z equals negative 4, or the order triple negative 1, 3, negative 4.